I've been buying, selling, collecting, repairing, and restoring vintage audio equipment for a long time. For about the last 2 or 3 years, I got very serious about it, and I started to make repairs for friends of mine and for folks on the internet through eBay, through Facebook, and just through word of mouth. Well, during that time, I met a lot of folks in the hobby, and one of my good friends in the hobby buys and sells equipment on a regular basis. One day he called me and said, "Hey Bob, I have an Onkyo M-510. Would you be willing to take a look at it for me? I just want to make sure it's working before he was planning on buying it." I said, "Sure, bring it over. What's the big deal?" "It's just a big amplifier." I had no idea what to expect. And this amplifier came to my shop, and I was barely able to carry it down the stairs here into my basement. It weighs 160 pounds, maybe 150 pounds, but it weighs a lot. It puts out 300 watts of power into 8 ohms at a total harmonic distortion of like 0.03 at rated power. It's absolutely crazy. So I put it on my workbench. I quickly found out that it takes up the entire workspace that I have. And I also learned that my isolation transformer that I've been using for a long time is not big enough to power it. So we tested it as best we could. It seemed like it was working, and then he took it home. Fast forward about 2 years, and I was looking for an amplifier for my own personal system. And I called him and asked if he had still owned this amplifier and if he'd be willing to sell it. And we worked out a deal, and lo and behold, it's back here in the shop, and now it's mine to own. I've worked on a lot of really interesting vintage audio equipment, from Macintosh to Conrad Johnson to all the Japanese brands, but never an Onkyo, and by far nothing ever this intimidating. It's intimidating because there wasn't very many of these built, and there's not a ton of information available online aside from a few poor scans of the original service manual. Something like 200 thereabouts were sold here in the States. And when they come up for sale, they're very valuable, I think mostly because of how rare they are, but also, I mean, just look at it. Macintosh amplifiers are cool with the blue meters, but this really makes like a 2205 or 2105 or even a 351 amplifier. This makes those look small, and that's really saying something. My plan with this amplifier is to basically give it a complete once-over. I know, obviously, the electrolytic capacitors are ready for a change, and I'll be swapping new ones in. I'm going to go through all the boards, clean them up as best I can, and do as much load testing as possible. There's really interesting circuitry in this amplifier in regards to the bias circuits. I'll get into some of that later on. And there's also some really interesting controls for the like startup procedure for this amplifier. There's a whole row of lights up here, and supposedly when you turn these on, there's a little song and dance that it does. It basically heats up the amplifier quicker for the first few minutes, and then it cools off a little bit. The manual even says to let this warm up for like 15 minutes before critical listening. Now, truth be told, I think this works. When it was here a few years ago, I plugged it in. As I mentioned, my isolation transformer was not large enough, so it would kick the amplifier in and out of protection mode. But I remember plugging it directly into the wall and putting a test signal through it, and at least checking the scope to make sure both channels were functioning properly. I trust my friend. He said it was working as well, but something this old, built in the late 80s, early 90s, when it's all original like this, I feel as though every time you turn it on, you're chancing something catastrophic. And that's why I'm going to test it this one time and then immediately get into the restoration. And I thought, there's no better time to take a video of this amplifier than the first time that I turn it on. And my plan is to feed it a signal through my signal generator. I have the output connected to my dummy loads, which are not rated nearly high enough for an amplifier this size. I'm just going to put out a nice clean 20 watts. I'm going to make sure the meters work. I'm going to make sure the controls work. And then I'm going to get going. There's not much information, as I said, available online. And there's only 1 or 2 videos I've seen regarding the detail of how these amplifiers are built and constructed. So I'm looking forward to taking my time and documenting the process, not only for myself, in case I ever have to work on it again, but in case a technician or another collector comes across one in the future, and they're just interested to know how it's built and how it works. So, without further ado, we're going to try this out. I dimmed the lights in my workshop here, so hopefully we get a good view of how the meters are backlit. I'm out back here making sure all my connections are good. I have my dummy loads connected to the back of this amplifier called System 1. This is an amplifier with 2 sets of speaker outputs. We'll be using System 1. And behind this bottom screen, bottom faceplate, which is all aluminum and it feels awesome, is this really neat rose gold color and the controls for the amplifier. So obviously the big button is the power button. Then we have a switch to dim the lights on the meters. This is for meter range and turning the meters on and off. This amplifier has 2 sets of inputs. One set is a direct, and one set is called variable. The variable set of inputs passes the signal through these potentiometers, and that's what I'm going to use for testing today. It's interesting. They're labeled in -dB. Here's your unit of measurement right here, and it's funny, infinity is actually up here at the top right. Just an interesting way of operating this amplifier. This switch here is what lets you pick between the variable input and the direct input. And then finally, speakers 1 and 2, that's where you select them. Now, up here, this top light is the weighting monitor. And this is where a sequence of LEDs will start from the outside and come in as it warms up. Here is a couple lights to tell you what meter range you're in. And then finally, a couple indicators about which speakers are on. So frankly, I'm a little intimidated, a little nervous about doing this because I don't have my isolation transformer connected to it. But I've rechecked my connections a few times, and I'm ready to give it a shot. So first thing is first, I guess cross my fingers, and I'm gonna go ahead and turn it on. So here we go. A lot of clicking. Oh wow. A lot of interesting things to talk about right off the bat. The weighting monitor started in the center and then it went out gradually to the outside. The lights on the meters are beautiful in person. It's breathtaking, honestly. These are clearly some really nice incandescent bulbs, and I know the video isn't picking up on this, but the meters are spectacular. Okay, so turning the meters on and off, we'll turn off the indicator light, and then selecting the two different meter ranges. I see the needles move a little bit, and that's probably somewhere in the meter circuit grabbing a little bit of DC. That could be a sign of a little bit of a leaky, maybe coupling capacitor of sorts, or isolation capacitor. I'm going to leave it in the ×1 range. And on this meter, the top scale goes from 0.01 watts to 800 watts at the far side, which is maybe the largest scale I've ever seen. These are the variable inputs, potentiometers, so we have those all the way down. I have variable picked, and I'm going to go ahead and pick speakers 1. I heard a good click. That tells me that the protection relay is letting us move forward. And with the variable inputs all the way down, I'm going to watch the oscilloscope and turn on my signal generator. And now with like a, I don't know, 2-volt RMS signal into the amplifier, I'm going to slowly turn up the variable input, and I'm expecting to see some output on this meter as well as a nice sine wave right there. That's a great sign. Good. So right off the bat, amplifier is working. Seems like it's working well enough. I mean, this isn't really a hard test right now. This is just ballparking it to make sure both channels are outputting clean signals. My test tone is 1000 hertz. And I'm going to go up a couple ranges on my scope. I'm really not going to push this. Number one, it's not warm. It's been sitting for a long time. And number two, as I mentioned before, the power supply, all the electrolytic capacitors are all original. And maybe it's a little bit of OCD, and I know the internet goes back and forth all day long about, do we really need to replace electrolytic capacitors? Well, I firmly believe we do, because the cascading effects of a failure of a capacitor in something like this could be really detrimental. I mean, it's working right now. We got lucky at this age. We're not going to count on luck anymore after this. One thing I noticed is it's been about a couple minutes, and the indicator lights for the waiting monitor have moved out, which tells me that the bias circuit's starting to work and heat up the amplifier. And I'm going to give it a little bit more output signal, and we're going to get into about 50 watts right there. Very clean signal here. And let's try 50 watts on the other channel. It is super handy having watt output on the meters. I can tell these potentiometers are pretty dirty because of the noise we saw on this oscilloscope, but that's to be expected. Okay, I'm going to give it closer to 100 watts this time. It's about 100 watt output. There's no ringing, so what I mean by that is sometimes when you put a pure signal like this into an amplifier, things like in the power supply and the rails will actually start to either vibrate, or the test signal tone will actually make it through the circuits, and you can hear it physically through the amplifier. And at 100 watts, it's quite a bit of power. On most amplifiers, you could actually hear the 1000 hertz. But so far on this one, it was dead quiet. I'm happy to hear that. It's funny, this is rated at such a high wattage, but most listening happens around 5 to 6 watts. And 5 to 6 watts is right in the center of the meter range. at a ×1 scale, and that's something I really appreciate. Because it's warmed up and seems to be pretty happy, I think what I'm going to do now, just to get a baseline on both channels, is set up a test where I run this through my total harmonic distortion analyzer. It's not the most fancy analyzer out there. It's not computerized. It's purely analog. And the quality of this amplifier will really test the capabilities of my test equipment. In fact, according to the service manual, total harmonic distortion at rated output is 0.005%. 0.005%. To put that into perspective, if you're not familiar with those type of specs, usually you could listen to something up to about 1% total harmonic distortion before you start to actually hear it with your ears. So 0.005 is orders of magnitude below the threshold of hearing. And here we are. We're like maybe 6 minutes into warming up this amplifier, and the lights have stepped out one more position here on the front panel. Before I hook it up to my analyzer, I'm going to do a quick close-up of this faceplate. The rose gold behind the lower faceplate is really pretty. And of course, it could be left closed like this. The meters, I know they're not coming across in this video, but it's a very nice, warm amber color. Like much more amber than I've seen on other equipment. Compared to the lighting in my shop here, it's really, really striking. And honestly, like most folks would think, well, let's replace them with LED or LEDs, but I think you lose some of this really cool warmth effect when you do that. I'm going to let this warm up a little bit longer at 1/3 power, which is where most amplifiers will be least efficient, so it should be heating it up sufficiently. I mean, we're putting out 2 watts. What the heck? This thing is so large. I might as well go to 5 watts. I'm just going to leave it like that for about 5 more minutes, and we'll see what the total harmonic distortion looks like. Well, without getting into a bunch of talking about my test parameters, I've discovered that the total harmonic distortion is nowhere near what it should be. So if harmonic distortion, according to the specs, is less than 0.005%, we're putting out about 20 watts, and on my total harmonic distortion analyzer, I'm on the 0.3 scale. So really, it's registering around 0.1% total harmonic distortion at 1000 hertz, which is frankly not very good. Most new amplifiers would exceed that without any question. And it's making me wonder if the problem I'm having is actually with my test setup. So I'm going to let everything warm up a little bit more, especially my analyzer. But right now, this left channel is off when it comes to total harmonic distortion by quite a bit. And the right channel is about a little bit closer, marginally closer. But I'm going to keep testing just to make sure I'm not, maybe I'm heating up my dummy loads, but I highly doubt it. I'm going to do some more testing, but as of right now, it seems to me, based on everything I've done so far, even though the signal looked nice on the oscilloscope, there's something else going on. And it tells me maybe we have to do some troubleshooting once we get into it and start servicing the amplifier. So that's why before I work on something, I I run it through all of its paces. Let's get a good baseline, and then we'll start getting into it. So, yeah. One drawback to working on this amplifier on my bench is normally I could just get around the back of the amplifier and make my connections, but not possible on this one. I actually have to walk around the back. One thing I just noticed as I put my hand over top of this, the top of the amplifier, this thing puts out a lot of heat. Much, much more than I was expecting. Now, I guess it's a huge amplifier and it puts out a ton of wattage, and I've been running it semi-continuously at around 20 watts, but it runs hot. I guess that's the whole point. So, okay. All right. So this is basically like the intro video I have to this amplifier. I didn't want to make it, way too long, but here we are already. And I think I'm going to start to get into this amplifier in the next video by taking all the faceplate off, the top off, the sides off, all the cosmetic, and start to look under the hood and see how things are laid out. And I'll probably start the process with the power supply. And I might even rebuild the power supply before getting into the amplifier boards. And maybe if I have enough time and I could stay organized, it would be nice to come back and continually check the total harmonic distortion to see if we can maybe pinpoint which part of this amplifier is not up to par. And maybe I'll find out that it's the whole amplifier as a whole has just aged, and maybe it's not just one or two things that are causing the rather poor performance, but maybe it's just a combination of everything. Maybe it's the power supply plus the amplifier boards. Maybe it's the filter section. Maybe it's the potentiometers I'm using for this input. Maybe it's the bias is set real low, even though it's running at what I consider to be a nice warm temperature. Who knows? It could be one thing, it could be everything. But that's the whole point of this hobby. I really enjoy learning about some of these weird amplifiers and receivers. And this one is the most weirdest one I've got to work on. So I hope you'll stay tuned. I'll probably have a follow-up video with everything apart, and I'll review some of my testing results. And I'd like to have that up in the next few weeks, maybe even sooner than that, especially if the weather continues to be so crappy outside. It's nice and cool down here and dry, so I'm gonna spend time down here as best I can. All right. Thanks for watching, and stay tuned for the next video.